Let S be an infinite subset of R such that S intersection Q is a empty set. Which of the following statement is true? First statement is S must have a limit point which belong to Q. S must have a limit point which belong to Q complement. S cannot be a subset, S cannot be a closed set in R, and S complement must have a limit point which belong to S. Means we have to solve this problem means for limit point. So for limit point we have some definition and some special notes for these questions. So the definition of limit point, a point said to be a limit point for which each neighborhood contain at least one point of this set different from it. And first note point is, this is the definition, and note point is limit point may or may not belong to the set. Suppose this is set 1 upon n. This set contain 0 is a limit point. Sorry, this set has a limit point 0, but 0 not belong to the set. Finite set has not limit point, means there is no limit point of finite set. Discrete set has no limit point. That's why set of natural number and its subset has no limit point. Means if we are saying root 2, root 3, root 5 and so on, this is either finite or infinite but has no limit point. The set of irrational neither open nor closed. This is very important point to solve this problem. Open intervals contain many rational and irrational. You already know this very well. Now come to the option and try to solve one by one. First option is S must have a limit point which belong to Q. First, what is given to us? S is infinite subset of R such that S intersection Q is empty. So this is set of rational. So what will be? S contains irrational points. Irrational means S is the subset of Q complement. It may be proper or it may equal to Q complement, means set of irrational number. But S is infinite. S is infinite. Otherwise, if S is finite, then no limit point will exist. And we can easily discard some options regarding this. So keep remember this discussed point. Now S must have a limit point. Must. This term is saying S must have a limit point which belong to Q. So S is set of irrational. So consider root 2, root 3, root 4, or you can indirectly say S is root P where P is a prime. Then this set S has no limit point because of this is discrete set and this set has no limit point. So option A is false. Option A is false. Now come to the option B. S must have a limit point which belong to Q complement, means R difference Q. S must have a limit point which belong to R difference Q. So B is S must have. This again must. So this statement is again wrong because S may be discrete. S may be discrete. If S is discrete set, then no limit point. So we will cannot be discussed. It is for rational or irrational, means limit point is existing in set of rational or irrational. That was the later point. So B option is again false. Now come to the option C. S cannot be a closed set in R, as S is set of irrational, and in the note 4 we already discussed S neither open nor closed. Nor closed means no limit point. So S cannot be a closed set in R. So consider, for further discussion, we can recall some point. S cannot be closed set in R. S cannot be closed set in R. For this statement is true. Why? Because if S is Q complement, means then there exists a P belongs to Q such that P minus epsilon and P plus epsilon, this interval contains many rational and irrational. Many rational and irrational, as we discussed in note point also, intervals of R contains rational and irrational. Hence this P limit point becomes limit point, and this P is Q, not belongs to S, means not belongs to S. That's why S cannot be closed. Now option D, come to the option D. R minus S contains, R minus S must have a limit point which belong to S. R minus S is set of irrational, so R minus S will be either subset of Q, means subset of rational, and again this is subset of rational. So consider N, or set of natural number, which is subset of Q, then no limit point for set of natural number, and this is saying must have a limit point which belong to S, means no limit point, it is rational and irrational. That was the point, or that is the point of later discussion. But set of natural number have no limit point. So again this statement is false. So only correct correct or true statement is C. This is true statement and other are false statement.